Good afternoon, everyone. Thank you for coming. I'm very excited to have Richard Socher with us, the Chief Scientist of Salesforce. Richard did his PhD with Chris Manning at Stanford, and I think he's, one of probably maybe even the most responsible person for all the methods that we use today in NLP. He really did a lot of the pioneering work using deep learning methods for NLP, and definitely left a significant mark on the field. I think now that's what everybody's doing. More recently, he's been interested a lot in models that can really learn core linguistic reasoning and then do basically all the tasks that everybody's been optimizing specifically for NLP in kind of a very general way. So let's welcome Richard. Thank you for joining us today.
Thank you. I usually don't need microphones, but I just got sick 2 days ago and I didn't want to cancel last minute, so I'm glad there's nobody in the first row. Sorry for you. Yeah, so sorry for my voice. Got a little cold. Very excited to be here. I want to talk to you today about the Natural Language Processing Decathlon, or decaNLP as we call it in short. And this is a lot of work by Brian, the first author of this paper. I actually had pitched this project and several others, like language modeling for all the things, which for several years. And most people kind of looked at what I was trying to do and said, this is just too much work. Like just pre-processing 10 different data sets to all have the same tokenization, the same pre-processing, and so on is like several months of work, unfortunately, because the field has all these different subgroups and sort of tasks and so on. So most people, it was just too much work. For them, Brian really dug in and didn't give up until we had some first results. And then Nitish helped us a lot on the optimization front, and Saming's our director of research, and he helps pretty much all our papers and is really phenomenal to have around. So I'll give you a couple of motivations of how we ended up and why we ended up thinking about multitask learning. And sometimes to see if you can predict the future, it's good to take a step back and look at the past. And I sort of looked at, since 2010 and before, a few years before, sort of what were the general steps that we took as a field. And the way I see it is we did a lot of machine learning with feature engineering sort of pre-2010. And then around 2010, me and a lot of others started deep learning for feature learning. And of course, like deep learning had started before in computer vision, but 2010 we sort of tried to use some of those ideas in NLP as well. And now I think we're currently in a state where we kind of do deep architecture engineering for specific tasks. We look at a certain task and then we think about, what kind of neural network architecture could do this task particularly well. And so in some ways the question is, what's next? Should we just continue to look at a task and then try to engineer this architecture? And so I think there are a couple of limits to this kind of single task architecture engineering. In general, I'm personally not that surprised anymore when you take a specific data set, task, model, and define metric, and then just try to optimize in that setting. And I think as long as we have roughly 1,000 times the number of classes in the output, in terms of how large the training data set is, we can probably do that to a degree where it works well enough to be used in an actual product. And in computer vision, that means you have 1,000 images per category, so you have 1,000,000 images for 1,000 class data set in computer vision, or like ImageNet. In machine translation, 1,000 is pretty hard to have every single word appear 1,000 times, so you have some kind of power law, Socher law distribution, but in general, I think this is like a rough estimate of where if you have a reasonably distributed number of examples like this, you can do pretty well. But just like this little dog here, it's unclear that to me that we'll ever get to more generalized natural language processing systems if for every task you restart from random. And another sort of line that led to this thinking is that we don't actually start fully from random. we have identified sort of pre-training as a good strategy in a lot of different areas of AI and deep learning as a positive strategy to get to better accuracy more quickly and have some kind of transfer learning. And in computer vision, that sort of galvanized the whole field because classification was sort of one of the major blocking tasks. And they showed, oh, if you have a pre-trained image net, pre-trained convolutional neural net, you can just kind of change the last couple of layers, backprop into it, and it'll work reasonably well. And in natural language processing, we also have some of this pre-training magic with word2vec or GLOVE or Cove or Elmo and now BERT. And the limited is soon, it's less and less limited, and it's more and more just a success. But even with BERT, it's actually still a different model for each different task. And it's not like it's the same model. You just run it for every single task. You have the top layer, and it's different if you want to do span and track extraction. It's different if you want to do classification, and it's different when you want to do translation and things like that. So there isn't really a single blocking task in NLP where everybody's like, sure, if you solve that one of 90%, we'll all use that model, unlike computer vision. And so you might ask, okay, why hasn't it happened more? Why haven't we shared more models and weights, and not just the first couple of layers of word representations? And I think part of it is because NLP requires many different types of reasoning. Right? You have logical reasoning. You can say, like, 2 people were in the room, 2 people left. Is there still anybody left in the room? And that's like very different kind of reasoning than some emotional or sentiment reasoning where you say, this is a typical Nicolas Cage movie, which for most people means it's a pretty negative movie review. I don't want to judge people's taste in music in movies. But we also have sort of short and long-term memory. It can define a new kind of system and a new kind of world where you say, like, time travel works, and then you can talk about it and reason over it and then jump back out. And so I think partly because of the complexity of natural language processing in the last couple of decades, people sort of divided the field into separate and intermediate tasks. And then there's some amount of benchmark chasing inside each of these separate and intermediate kinds of problems, like just part of speech tagging and entity recognition. And that made sense because then the field finally made some more progress. And now the question is sort of what comes after this? How can we share even more weights of these models and move beyond just sharing word vectors or contextual word vectors? And some people say, well, maybe we should work on a single unsupervised task. And I certainly think an unsupervised task like language modeling can be a big part of it, but I don't think language is a purely unsupervised kind of endeavor. If you put like a kid into a jungle, it'll develop a pretty good visual system, visual cortex, but it's not going to develop language by itself, right? So you do need some kind of supervision for language. And so you might ask, okay, why would all of this lead to trying to build a single multitask model, which is our goal for decaNLP? And I think there are a bunch of different reasons for it. One, I think just as an intellectual endeavor, I think it's a pretty clear roadblock towards more general AI, NLP models, ideas, and systems. It's also an important building block for sharing weights and sharing different models, for transfer learning, ideally to improve performance. Of course, there's sort of the other side of that coin, which is not having catastrophic interference and forgetting as you're training multiple different tasks into the same model. Eventually, I want to see zero-shot learning capabilities, where even if I ask a question that has never been asked before, I still want to be able to get an answer from a generalized NLP system, and then have sort of the simpler version of that with domain adaptation. I also think in terms of concrete productionizing of systems in companies, it will be very useful once we have a standard architecture that we can kind of throw at most every NLP problem, and it'll just kind of work. Instead of right now, if you have a summarization team, a chatbot team, a translation team, and so on, they all use slightly different models, and it's very hard to deploy these models and then have sort of the expertise in the company long term. I think it will also eventually lower the bar, just like now if you want to write a squirrel detector to attach to your water gun in your front yard, like you just use a CNN that's off the shelf and it'll just kind of work. Ideally, we have something like that for NLP2 for a broad range of different tasks. And then in the end, we want to have the models decide how to transfer the knowledge versus us sort of manually deciding that. By the way, if you have any questions, just raise your hand and let me know. I don't know if the folks in Ithaca can have another communication to our side, but feel free to interrupt us also. All right. So that leads us naturally to the question on how we can express these different NLP tasks in the same kind of framework. And they're essentially, I think, in terms of the structure, 3 different classes of tasks. We have sort of sequence tagging tasks in NLP, like native entity recognition, aspect-specific sentiment classification. We have just classification, lots of different types like sentiment, dialogue, state tracking, and so on. And then we have a whole host of different sequence-to-sequence tasks. Translation, summarization, question answering. And I actually love those last 3 tasks because they are, in some ways, the most concrete. If you make those better, they're immediately useful in the product, but they're also interesting intellectually. And from a research perspective, they're very hard in the limit. They kind of, have to have a full understanding of language and the human condition to really do them perfectly. So the upper bound is very, very high for what we want to do. And in the next couple of slides, you'll see that we'll try to also focus more on sort of really useful NLP tasks rather than intermediate representation. So as much as I love parsing, it's kind of an intermediate task. And sometimes it turns out that you do a lot of these 3 things, for instance, without any understanding of a syntactic parser. So I've worked on that myself during my PhD, but I'd rather now focus on tasks that are sort of end-to-end trainable, and where it learns whatever representation needs to learn as part of the model. So this led us to thinking about sort of the 3 equivalent, I call them super tasks of NLP, where I'm arguing that pretty much every NLP task can be cast into one of these 3 types of tasks. So language modeling, something we've worked on for a while in the group with Stephen Merity. Basically, if you try to predict the next word and you ask a question about, what were the part speech tags of this sentence before, who's the president of Zimbabwe, like what's the translation into German, like the next couple of words you're supposed to predict, this could all be part of a language model. Question answering, everything can be cast as a question over some input document, and everything can also be in a dialogue where you go back and forth. Now, language modeling, I think, is super exciting, but for the most part, the models that we use for language modeling won't be very good when it comes to extracting spans and referring back to things in the past. Dialogue right now, there are not many great data sets out there, and most tasks, if you map into dialogue, it would be just a one-step dialogue. What are part speech tags? This is it. So it's kind of a little too much. So we converged to question answering as our main task. And so I hope you can read this, but I'm going to go through these in a little bit of detail here. These are essentially the inputs that we have for the model we want to train. Literally exactly the way they're phrased right here. So these are 10 different tasks, and each of these is basically cast as a question answering problem over some kind of context or input document. So the first one here is the standard question answering kind of problem, like SQuAD, Stanford question answering data set, where you ask a question over a Wikipedia paragraph, for instance, and the answer is always a specific span from that paragraph. But you can also ask, what is the translation from English to German? And you basically have an English context sentence, and the answer is that sentence in German. And here, the answer doesnst come from a span from the context, but it's usually a bunch of new words that are coming from this separate classifier. You can also ask, what is the summary of this input document? And then you have a mix of some new words that might be generated and a lot of extracted spans and words from the input context. Then, and this one is a little less intuitive, but sort of natural language inference and entailment classification. can also have here, and what's important in how we formulated this is that the hypothesis and the output classes are part of the question. That will be a pretty important detail in the future. So here again, for instance, for sentiment, we also say, is the sentence positive or negative? And we don't just ask, what's the sentiment? If you do it like this, the model will eventually learn to point to these adjectives based on this context. And what that will allow us to do is eventually point to words that it's never seen before. And that will be a crucial part of how we can do zero-shot learning, where we can ask also, is this story happy or sad? And based on whatever correlates here with these adjectives, it can learn to answer and basically do classification, like zero-shot classification. And then we have a couple of other tasks like semantic role labeling, relation extraction, dialogue state, tracking and classification, some semantic parsing, where we translate natural language English questions into SQL queries, and then some common sense reasoning here with Winograd schemas. So basically, all of these tasks we cast as a question answering problem over some input. And what that also means is that in some sense, this is a meta supervised learning kind of framework where we pulled out the task that we cast as a question, and instead of saying that's sort of external to the model, we pull that into the model as another input. And once the task and question that you're looking at is part of the input, you can now train a model over a bunch of different tasks. Are there any questions about this formulation? All right. Yeah, so basically here, the task T is our question. And you might actually say, well, do we really need to have like a question? Because for some of the tasks like summarization, the question is the same one every time. So, whether you ask what is a summary or just, S token or summarization, have a special token, doesn't really make a difference. But if we want to have it be all part of the same kind of formalism, then it's nice because we have here a couple of the tasks that actually require us to allow for different kinds of questions, like who is the illustrator of cycle of the werewolf? That is actually a different question for each input. Same with standard question answering like squad. Yeah. Okay.
So does the answer has to be text? I was wondering about extracting things from text that might not be text themselves. So a graph representation of an argument, or even in the case of relation extraction, if you have like a template of information that has multiple relations that you want to pull out as the kind of summary of the input.
That's a good question. So in some sense, I guess we have some examples where it's not quite text. So here we have like code, like SQL code. And if you can describe a relational graph as a sequence of, tokens, I think that would also be okay. So you could use the same formalism, even if it's not exactly like natural language, but it could be some kind of graph language.
But in those cases, the zero-shot learning wouldn't really be an option.
It might still transfer like some types of reasoning, but yeah, if you didn't include SQL as a training, it will never generate SQL as a zero-shot task. That's right.
So for tasks like semantic role labeling, you're thinking about them as like basically I'm going to ask multiple set of questions. So if I maybe what's the predicate, and then given this choice of the predicate, you're going to ask what is arg0, what is arg1, what is arg2, one by one.
Yeah.
And each of these questions will be asked completely independently, or?
That would be one way of doing it. You can also ask like, what are the arguments to this verb? And you include like the verb, like hitting or something or talking, and then based on that particular question, kind of give the answers. You can also have a sequence of questions, I guess. Based on the first answer, you then trigger a different kind of question. Yeah.
What models do you utilize to measure the distance between the original question and the answer in a semantic sense after translation?
So, I guess we'll get to the model in a second. it's more than just like a distance kind of thing. It's pretty involved, but yeah, we'll get to it. So, so what are the requirements that we want for this kind of model? Basically, we didn't want to have some sort of task-specific modules or parameters where we say, if you're working on this kind of thing, then just use those kinds of parameters. Because then you could just have 10 separate models, have a classifier in front, you say, if you're doing SQL generation, then run this model. If you do summarization, then run this model. So if you did that, then you wouldn't get any kind of transfer between the types of reasoning that you need for these different tasks. So we want the model to just sort of internally to perform all of these disparate tasks. And that hopefully will leave that possibility also for zero-shot inference on unseen tasks. All right, so all of those kinds of motivations and this new benchmark data set that we put out led us to the MQAN model, or the Multitask Question Answering Network. And so again, to sort of high-level summary, of this is you start with some kind of context document, then you ask a question over it, and then the idea of this model will be that you generate one word at a time by either of these three following mechanisms. You point to a context, and generally, actually, pointers are pretty amazing, right? Like, they were invented sort of on some graphs and neural networks, but this idea that we can point to inputs is pretty powerful, and it allowed Squad, for instance, to generate like the first model from Squad from Singapore Management University, able to create answers they've never seen before at training time over completely new domains and paragraphs on Wikipedia. So pointers are actually a pretty substantial improvement in NLP. So yeah, so either we point to a context word, or we point to a question word, or we choose a word from an external vocabulary. Sort of standard classification. And it will have a pointer switching mechanism between these three options. So I'm going to go over this model in a little bit more detail, but in some ways it's kind of like what Krzyzewski did with CNNs, which is we took kind of the best kind of pieces of deep learning for NLP, and we just kind of reasonably put them together. This whole model, code, and leaderboard, and everything is all online on decaNLP.com. You can go on GitHub, run one command, and it'll download all the data sets, pre-process all the data sets, train the model, and spit out training and testing. And because we've made it so easy, we've actually had like thousands of, over 1,000 forks and likes and whatnot, stars on GitHub. And we've had a lot of people in industry use this model for whatever NLP task they have. Because as long as you can pre-process your data set into this question answering format, you can use this model for the task. Yeah, so we'll go over this model in a little bit more detail. So you start with word vectors. I have sort of fixed glove embeddings. They're actually pretty important to have some fixed embeddings where you don't backdrop into them to generalize to unseen kinds of words. But then we also have character n-gram embeddings for unseen words. We pipe those through a simple linear layer and then have a shared bidirectional LSTM with script connections that are going over the question and the context. Then we have this co-attention mechanism where you essentially just have a bunch of outer products of the hidden states of the LSTM. And you sum those up, and then you pipe them through another LSTM. And then we also have two transformer layers. I actually really wish we could have tried to have just transformers for all the things. But unfortunately, they're still really finicky, and they're really hard, and you need to really play around with the optimization. In the end, they're just not that stable and didn't get as good performance. So we still need to have a bunch of these LSTMs for the model to really be robust and work well. And then we basically have a standard autoregressive decoder. We will just generate one word at a time. And the way we do this is by essentially taking these sequences input and then generating a question pointer, words to that question, pointer to each word in the context, and then we sum all of those up together with a standard softmax classifier over the whole vocabulary. Any questions about that model? In some ways, if you're not familiar with deep learning NLP, it's probably not very useful. But hopefully folks here are all familiar with LSTMs and transformers and stuff. If not, and you do want to learn a bunch about it, all these models are explained pretty well in the class that I used to teach at Stanford, CS224, n.stanford.edu. Any questions?
So then you're combining the distribution, the three different distributions?
That's right, and they're all combined.
And this is like basically using some hyperparameter for...
There's no hyperparameter. It learns the weights. They're also part of the output of the model.
So I have a question. How did you transform the sentences into the numbers?
What do you mean by numbers? Which numbers?
Because in the first layer, the question and the context, there are some neurons. They are actually numbers. So how do you transfer the sentences?
Those were fixed glove word vectors, and then character and grammar embeddings that were trained as part of the model. So that's how you get from words to just a list of numbers by looking up which word vector you use, and these word vectors capture essentially distributional sort of contexts, like which words, words that appear in similar contexts will get similar kinds of word vectors.
So did you try to tune the glove embeddings?
We do, but as soon as you backpropagate into glove embeddings, you will just overfit. One, you overfit even more, and two, it won't generalize anymore to unseen words that you've never seen in training. So that's a pretty important piece. It drops by like 20–30% accuracy on squad, on any of the squad models, really, if you backpropagate into fixed word vectors. So none of the question answering, sort of standard question answering kinds of things work anymore if you do that.
So you didn't need any special mechanisms to keep repetition down, or?
That's actually a good point. Like, we know our MT numbers would be a lot better if we started doing nice beam search and so on for certain kinds of tasks. But on this first one, we tried to use the exact same formalism for pretty much every one of the tasks. So I think that's a pretty low-hanging fruit to try to get better numbers, is by just adding sort of a beam search that gets triggered when it makes sense to get triggered, and learn that mechanism. I think that would be, and you'll see soon, like, our MT numbers are the worst numbers also of all the tasks that we have. So here are our 10 tasks. We've thought for a while maybe we can just use normalized F1 scores for all the different tasks, but then, you know, each sort of subcommunity has its own metric for a reason, and we want to make sure we're still comparable on all the with previous state-of-the-art and previous results. And so we're basically stuck to the metrics that each subcommunity uses: normalized F1 scores, blue scores, and so on. And we also stuck to data sets that are publicly available, where you don't need to create an account, pay a bunch of money to the LDC and so on, but you can just wget and get the data set. And so that's one of the reasons why we ended up with these 10 different tasks. And then, as you can also see, we tried to sort of stick mostly to tasks where we saw like a real use for that kind of task. So again, these three really hard and interesting tasks: question answering, MT, summarization. And then, you know, you could argue about inference, NLI, and SRL, but at least like there are a lot of like information extraction systems or so on that would be very useful to have these as inputs. Yeah.
How did you generate the how did you generate the questions that you ask? For instance, for machine translation, do you ask it to translate to something the same way every time? Like,
yeah,
was this in German?
And then we thought about also making it more robust so that people who interact with the system could ask it in all kinds of different ways. But in some ways, it's just a pre-processing step. So we just had this exact formulation: what is the translation from English to German? And if we added other language pairs, we actually had an internal sort of fun run with 24 different tasks where we included like the same kind of task multiple times, like multiple translation pairs, and we just changed like what is the translation from German to French or something, and that's how we formulated all of those. And then, yeah, what is a summary is the same question for all the summaries, but then some of them are different for SRL, and especially for zero-shot relation extraction too.
One question. So Is there a way to know what task the model is trying to solve, or like is there a latent variable that you can maybe just evaluate or just know?
Sorry, did anybody understand?
No, it's asking, is there a way you can tell which task the model is trying to solve at a time?
Oh, great question. Is there a way that we know which task the model is sort of thinking about and it's doing? Part of the hope was that we don't have to tell it that at all. And we actually believe, based on some analysis I'll show you in 3 or 4 slides, that the model is able to figure it out pretty accurately, but fortunately in some cases doesn't have to, because there are some sort of transfer learning pairs where joint training helps, and then there are a bunch of tasks where joint training hurts. And so the model, for the most part, is able to generate the right structure of the output. That's a great question. We'll get back to that in a couple of slides.
So what's the motivation that like you gave the task as a natural language query, but not like in another format, like I want you to do this task or that task, like
as a command instead of a question?
yeah.
I mean, in some ways, commands and questions are kind of like summarize this document versus what is the summary is kind of similar.
Categorical representation. So why is it like language? Like
Why question at all? So part of it is that some of the data sets actually have that format. So, like squad or zero-shot relation extraction, semantic role labeling, and some of these actually have that as a thing, as their format. And so it would be artificial to switch it. You're right that you could just say, what is a summary, and just say, okay, this is just summary, and that's just a token. But then for some of the classification tasks, it actually is very important that you include the labels in the question, because that will allow you to eventually do zero-shot classification, because you're learning to point rather than generate from softmax. Once you learn to point, you can use that same idea to do zero-shot classification for tasks, for labels you've never seen before. And in some ways, it's also just more intuitive for anybody to use this. Instead of having to define some kind of domain-specific language for their tasks and so on, they just like ask the question: why not interact with NLP systems with NF? But mostly it's because 4 or so of those 10 tasks come naturally. Actually 5, I guess, pronoun resolution too. So several, like half of the tasks come naturally in natural language, and we wanted to try to have a single formalism for all of them. I do think there are a lot of other formalisms you can use, like language modeling or dialogue systems, or like commands and things like that. It's certainly, like, you can work on decaNLP and get all the metrics, even if you rephrase sort of how to define the task. So you're not tied in decaNLP to use question answering for everything. So the way we define success for this is by just basically summing up all these 10 different scores. They're actually, fortunately, all theoretically between 0 and 100. Now, of course, blue scores of, you rarely ever see in the 90s, so it's not quite out of 100 in real life. Is there a question? But in general, this score now goes, instead of from 0 to 100, from 0 to 1,000. And you might also argue, oh, should we have it weighted or not? And you can actually argue for weighted and against weighted and so on. So we just kept it simple and say, all right, it's just the sum of all these scores. There are some lower hanging fruit, and this actually also tackles a lot of the problems that we have in AI in general, like imbalanced data sets, where some data sets are much, much smaller. Like Winograd must have a couple hundred training samples, and machine translation has a couple of hundreds of thousands. But this is kind of why this is an interesting and hard challenge. And maybe you might argue it is actually too hard. So we'll talk a little bit about the results. So there's a lot of numbers here, so we'll walk through that through these tables very carefully. Basically here on the left, the first 4 columns, we have for each task a separate model. And on the second one here, we have for each column, this is basically a single model that does all 10 tasks combined. So 10 separate models here, one single model for each column. Now the simplest baseline is just a sequence-to-sequence model. Then we added the self-attention and transformer layers. We have the co-attention, the outer products between the two sequences, and we have the question pointer model, and that's sort of the full MQAN model. And first thing we notice is self-attention and these transformer layers help on a bunch of different tasks, including WikiSQL. Fun fact, actually, WikiSQL turned out this 72 is actually the state-of-the-art on WikiSQL. Which is kind of surprising given that we kind of threw that in towards the end, like, hey, what's another useful data set and task? And we're like, oh, we had WikiSQL from our group, from Victor Chong, who's now at UW, and we just sort of threw it in there, and then it turned out to get state-of-the-art on this task. Yeah.
So I was wondering, does like every question require reasoning about one task? For example, it could be like, what is the summary of this text in Spanish?
I would love that sort of compositionality of tasks.
Yeah, so just to see if it's actually learning both of the tasks and using that information.
I think that's one of the goals of why I'm excited about this line of research, to be able to do that. Unfortunately, we didn't have any training examples of this kind, but hopefully we can do that in the future. It doesn't make sense to combine all of them, like what's the sequel in Spanish, right? It doesn't make sense. But for some of them it does make sense, and it would be cool to have some compositionality of tasks. And yeah, in theory, it's like, if you can translate into German and you can summarize, why can't you create German summaries, right? It's like, that's sort of, to me, one of the sort of end-level goals of multitask learning in NLP. Instead of having all these like big systems with a lot of if statements and so on in pipelines, you want to have just a single model that trains all of that. Another observation made is that basically question answering and semantic role labeling have a strong connection, so if one works well, the other works very well also, and they actually benefit one another as well, sort of. So training multitask works actually slightly better than separate training. So it's kind of intuitive, and basically right now what you observe in most multitask learning papers and transfer learning papers is sort of a high-level selection of tasks that are known to help each other. So if you work, you know like part of speech tagging helps in entity recognition a little bit, which helps semantic role labeling a little bit. So you combine those three and you get a nice transfer learning paper. Or, question answering with commonsense QA and squad help each other. Or Wikitext or WikiQA and so on. And so for the most part, in general sort of published results, you don't see the other side, which is, yeah, but when you try to combine these two tasks, they don't help each other at all. People just don't publish that, because if they try, it gets rejected. And so here, you'll see some of those positive connections, but you'll also see the negative connections. Then another thing we found is that pointing to the question is essential, even just for classification tasks, which was somewhat surprising. So pointing to this is an entailment rather than classifying entailment as a softmax helped. And then multitasking helps a lot when it comes to zero-shot classification. So here we have an almost 2x performance improvement on a zero-shot relation extraction. And to me, I'm most excited about these kinds of zero-shot tasks, because that shows me some generalization of the language capabilities. And then just to keep ourselves honest here, and so I guess one thing that I did mention is MT actually sucks in multitask. It's the one task that really hurts, and there are a couple of reasons we postulate for that. One is all the other tasks basically learn to point in some way, and so a lot of the underlying features are good for pointing. And then MT is the one task where actually there's a bunch of German words from a softmax. So it's not very helpful to have the rest of your language system learn to point, learn to parse, and learn English, and so on.
So,
yeah.
MT is the only one that has completely different vocabulary and output from the others?
Pretty much, yeah. And so you just have a lot of interference of the underlying, like all the weights that we got from this model up to basically here. All of this mechanism is getting better and better at pointing. And then for NT, it just needs to create a softmax. And then also on top of that, we don't have beam search and all of that.
But the majority, but when you train everything, actually the majority of examples are probably for MT, I suspect. This is the biggest data set?
It's actually, so IWST and Squad are roughly similar, like a couple 100,000 examples. Okay, so that's one. Another observation is, right now, if you had a perfect oracle, which we don't, that would identify which tasks you use, then this MQAN model with the question pointers and that whole architecture I described would basically get 586 if you sum them up. But our best system here is only 562. So you have more catastrophic interference between these very unrelated tasks than you have transfer learning between the ones that are related. Of course, you don't really have a perfect oracle here, so this is kind of a theoretical number. In some cases, it will be obvious, like what is the summary? That will be perfectly classified into summarization each time. But Squad, SRL, and zero-shot relation extraction are a little less obvious in their classification problems. So here, and again, we see also that they help each other. So now, one big question is, how do you train this? You have these different tasks, some are smaller, some are bigger, and there's some work on curriculum learning, where the idea is you start with simpler tasks first, and then you go to harder and harder examples. And it turns out that's actually the opposite of what works. If you do curriculum learning and you first do sentiment analysis, then the whole model just learns to do positive and negative, like very simple tasks. And then you try to ask all kinds of questions and translation and summarization. The model is kind of overfit to such a simple output space, and it doesn't work. So we tried a lot of different training strategies. The simplest one is kind of fully joined. You just take a mini batch from each of the tasks, and you go through them, and you train them. What we found better is actually what we call anti-curriculum learning, or pre-training, where we take the hardest tasks first that require the most reasoning and the most sort of understanding of different vocabularies and so on, different output spaces. And we train on those at first. And then after a couple of iterations on these really hard tasks, then we move on to the simpler ones. So with just that kind of anti-curriculum training, we already got another 9% or so improvement. And at this point, actually, we tuned everything a lot more, and we're currently at sort of 617 for this number, the Oracle, and 616 or so for this. So we're 1% in deca score away from closing the gap between 10 separate models and just a single model for all 10 tasks. But unfortunately, there wasn't really any super interesting insights from that tuning. We just tuned all the hyperparameters a lot, and that just kind of helped us close the gap more and more. But the anti-curriculum was sort of one more interesting result that helped us close that gap. Now, this was sort of the question I think that came from you, is like, how does the model know how to generate the task? And it does seem like it's pretty good in knowing that depending on which question, it knows how to generate the answer in terms of doing the softmax vocabulary, creating context pointers or question pointers. So here is that sentence positive or negative. It basically just points almost always to words in the question, namely positive or negative. So it's not really confused on how it should perform these kinds of tasks in output spaces. Now, why do all this if, you know, the 10 step, I mean, on the first actually is like, even if this was the case, it's kind of amazing that we can have a single model that gets pretty close to state-of-the-art numbers on 10 different tasks. And it's basically the exact same model. There are no if statements, if this block, then this block, or so on. But it's also useful to have this kind of decaNLP pre-trained model. Basically here, we tried some new tasks that we didn't see before, like named entity recognition or English to Czech translation. And we basically showed that it converges more quickly and starts at a higher blue score or exact match score, and also is, even after training, still slightly better than a randomly initialized MQAN model. So this is kind of pre-training, but pre-training to the absolute limit of what pre-training could do, namely the encoder, all the reasoning, and the decoder. It's all pre-trained. The question and answering formalism is fully pre-trained. versus like, you pre-train and you slap like different kind of nodes on the top for each task. And that was true for both of these tasks. We also did a bunch of zero-shot domain adaptation, where we had sentiment, SST, Stanford Sentiment Tree Bank, which was movie reviews, but then we tried it on product and restaurant reviews, and just without any training, immediately achieved 80% accuracy. And then SNLI, which is a different NLI data set, also out of the box achieved 62%. And then if we fine-tuned the model on the SNLI training data set, got to 87, which was still 2-point gain over the randomly initialized MQAN model. So if there's some kind of task that is similar to the task that you've had in training, it'll just kind of work for several of these. And then this one is actually the one I'm most excited about, and it's probably something that we can, and hopefully others will also kind of expand, and that is that this question pointer allows us to have zero-shot capabilities. So we tried here a different context, namely John had a party, but no one came and he was all alone. And then we asked, is the story sad or happy? Now there's never in the training corpus a sad, happy, like here are 500 sad stories, here are 500 happy stories, now train for happy or sad classification. So it's completely zero-shot for that kind of task with these kinds of labels and so on. And it basically learned to point to the word sad, and hence like answer this correctly. And it doesn't work for all. Like we can, when we try and we change the structure of this too much from, is this like sentence positive or negative, and we like change the structure a lot, eventually it'll get confused. But just that, it could have also pointed to came or like the party or something, right? It's kind of amazing that it generated the right outputs. And in most cases, it would either confuse the two adjectives, which is cool, but it gets it right a lot of times. So, but these are all kind of anecdotal, right? So ideally, we'll create another data set, but it's actually hard to come up with a bunch of zero-shot, zero-task kind of examples. Yeah.
So, could your model have an explanation why this user was sad but not happy?
So why does it actually work? So my hunch is that it essentially learns to correlate in these models that there are certain words in the context here that it will correlate in some kind of space with some of the words in the question. And if there's some correlation between these words and that word, then it'll kind of is more likely to get it right. That's the best explanation I could come up with. Does that make sense? But it's definitely good research to dig more into this. Like when does it work? How often does it work? Creating like a separate zero-shot test set, kind of similar to these things that we did here for sentiment, but for not just the adaptation of completely new adjectives and so on. It requires a little bit of like cleverness and creativity on like how to come up with that kind of zero-shot test set, because it has to have a bunch of different adjectives to come up with a bunch of different stories for all those adjectives. There's this like, was John clever doing this, or was he stupid, or like, I don't know, like lots of different adjectives you can come up with, or it doesn't have to be adjectives, it can be nouns too, like, is this an epic story, or a crime story, or whatever, like, there are lots of different things, but it's not like, oh, you just sort of run it through A&T and then you'll have it, like, you need to think a little bit about it. All right, so hopefully I could convince you that, this is a feasible thing to do. It's certainly not an easy thing to do, and it does kind of challenge, I think, a lot of the things that we do in the field. A lot of times, careers and PhDs and so on are built on like, I'm an expert in summarization, or I'm an expert in sentiment analysis, and that's the one task that I sort of built my career around. Just like 10 years ago, a lot of people built their careers around feature engineering and say, well, I know how to create good like parsing features. Why do I want to learn these if I can already do it manually? But to me, this is in some ways like the next evolution for the field, is to think, now that we had sort of subdivided the field into all these disparate tasks, now it's I think time to combine these different subfields again. And I think it is becoming more and more feasible. We think that decaNLP is a great framework for tackling or at least analyzing more general language understanding, multitask learning, transfer learning, weight sharing, pre-training, fine-tuning, zero-shot learning, and domain adaptation, all these different sort of pros and cons, and in some cases, catastrophic interference and all these harder issues that arise that are also harder to publish because they're usually negative results. There's a ton of related work. The paper has over 100 related works and citations. Here are some of the papers that we personally were very inspired by and sort of thought about when we did this work. And so yeah, that's kind of our answer for what's next in NLP. Maybe it's a single multitask learning model that can capture more and more of the complexity of the field. And it'll be hard, but I think very rewarding if we get it. Thank you.
Yeah, we have some time for questions.
Yeah, I was kind of curious whether or not you've gotten any opinions about how, so I assume the data set must be very, very, very large because you incorporated all these data sets. So we tried to do that in the past in the MQA space, and we ended up with a lot of people saying, well, it's so big, it takes too long to train. We won't have time for this.
Right.
So I was just wondering whether or not you thought about how do people have the computation resources to do it all in a reasonable amount of time in an academic setting.
Right. So we thought about that pretty hard, and that's one of the reasons we chose the data sets the way we did. One, they're publicly available, you don't have to pay for them, but also we did IWSLT and not WMT, for instance, which is a much, much larger MT data set. And we know, for instance, MT, language modeling, and so on, they help. But once you include them, it's like it takes months to train on TPUs, and so it's going to be hard for any normal group to train it themselves. All of this and the code that we made available, you can train on one GPU in a week and on a couple of GPUs in a day. So and the code is multi-GPU capable, sort of GPUs that are on a single machine. So with a large AWS instance, a normal researcher can still do it in a day or so. Now, I do think eventually it'll be better to have bigger data sets there, but part of the reason was that we wanted to keep it sort of available. And it's kind of interesting, like for question answering, there are some folks who work on generalized question answering. That's literally like what their workshops are called and everything. And when I ask them, like, can I ask your model about what the sentiment is of this tweet? They're like, go to the sentiment people. They're like, why are you asking me this question? I'm like, it's a generalized question answering track. Why can't your generalized question answering answer general questions? But it is, like I said, it's very much like in sort of sociology of the field to have these, I think in some cases, artificial separations between them.
Oh, like I have a question. If in your model so when you give the context, you add more context, your machine learning method is able to get okay, this is the extreme example. Like you have a question and you give an entire book. In principle, is able also to parse in the extra context and extract the right information.
In principle, yes, but in practice, no. Unfortunately, that is a problem that we're actually looking into right now. So how do we make this model more efficient? One of the problems is this co-attention layer, where you have the outer product between the question, all the hidden states of the question, and all the hidden states of the context. So if your context is like hundreds of thousands or millions of words long, that outer product becomes infeasible, run out of memory. So you'd have to chop it up into smaller chunks and then run all the smaller chunks multiple times. Or you have to learn to create a model that is kind of incremental, like you just keep on going with the same model, one word at a time, and it doesn't have to do any outer products or co-attention with the question. So I think with large enough, and this is kind of what BERT and this new model from OpenAI shows us, with large enough models, you may not have to do co-attention, but it kind of can keep track of the states that it's in for longer periods of time. So that's one of the many interesting sort of follow-up works.
You examine anything that is not a correlation?
What do you mean, not a correlation?
In the end, although the model does some complicated correlation between context, questions, and stuff like that.
Mm-hmm.
Is there anything else maybe that can be added? Like, I mean, I have an internal model of the world, and that influences my understanding of language.
I mean, in some ways, it's like, you know, you can be snarky and say most of AI and so on, deep learning is just correlations. But, you know, when you generate SQL, there's some kind of, you know, you could argue for some more general types of reasoning. I do think that instead of just having a question in a context, you may also want to have like knowledge graph as an input for all the things. You can have an image as input also, and then do multimodal multitask. But the thing is right now, it doesn't even work that well yet for just language multitask. And it's been hard to get this past some of the reviewers too, because they're so stuck in it. Like, I do machine translation. This model sucks on machine translation. Why would I ever care? Reject. And so, just like when I, in 2010, tried to submit the first deep learning papers, people are like, I already know how to design my features. Why need a more general model to learn my features? And like, until you have state-of-the-art numbers, people just very easily reject it if it goes against the things that they're very good at. And so, I think there are a lot of things you can eventually extend to this model, but I think right now there's still a lot of interesting tasks just in this framework.
Have you thought about summarizing the context for extremely long context and tack onto that? Could this model here, could you use it as the summary model for summarizing context before it goes into asking a question that's not summary?
So I like the idea of using this model to first summarize the input and then run it again through this model, sort of learning when to do what with the model. We have not done that. Seems like a cool idea.
I'm just curious if if you compare it to how people answer questions. Sometimes the problem is what to include in the context. In fact, a lot of times.
That is a great question. So we actually, some people said, oh, isn't that finding the context the hard part? But it turns out it's not that hard. Like we just hacked a quick thing together where we ask any kind of question, and it just uses a simple information retrieval system or Google or something, pulls out the first page, and then takes the Wikipedia page or something like that, and throws that as the context into it, and that actually works surprisingly well. So you could ask like all these squad-like questions with this exact model, and just have like an IR system to pull in context, and then it'll work pretty well. Which was kind of surprising to me. I didn't think it would be that robust to just pulling in random stuff from the internet, but I kind of did.
Okay, thanks, Richard.
Thank you.